Go ahead and go to the notes we're going to take. Right. Oh, incidentally, on this one, just really quick, this little R means reflection. Where's the line y equals x?
This is the line that goes across.
That's diagonal. Y equals x. Because where does y equals x? Oh, where does y equal x? Well, here, 1, 1. Y equals x, because 1 and 1. 2 and 2. Y equals x. 3 and 3. So when they ask for the line to reflect over the line y equals x, that's just going to be this diagonal line. All right, so you have to plot it and then reflect over that. Okay? All right, so let's go to the notes. Right here, we're going to do median of a triangle. So we're actually going to construct it using the compass today. But first you need to know what it is. So here's what the median of a triangle is. Here's a little picture. You don't have to draw it perfectly, but just to give you an idea. All right? So write these down. Write this down. Right? This is very important vocabulary you have to know. You have to be familiar with. Okay, when it says vertex, also wherever two sides meet of a triangle, that's a vertex. So every triangle has 3 vertexes. So wherever two sides meet, that's a vertex. And we're going to be able to find the midpoint. We've learned how to find the midpoint. Every triangle has 3 medians. So now I'm going to have you guys write down the properties. So if you're ever looking at a diagram and you know that there is a median, there are certain things that you can assume based on that. Right? So now we're going to go to the properties. So here are the properties. So if you know you have a median, if it says triangle ABC has a median of, you know, whatever, AD or something, we know that each median in a triangle divides the triangle into 2 smaller triangles which have the same area. So you can assume that if you have a median, that you have 2 triangles with the same area. Every triangle has 3 medians. If you were to make all 3 of them, construct them, which we will do, it's going to divide the bigger triangle into 6 smaller ones, and each one of them will have the same area, even though they may have different shapes. Also in red, that's another vocabulary word you have to become familiar with. When we do construct 3 medians, which we will on the sheet I gave you, where they intersect inside the circle is called the centroid. All right, let's go to the next part here. All right, so we're going to look at this triangle that you have, the first triangle on your worksheet there. All right, and we're going to first just construct a median, then we're going to construct all 3, which will give us the centroid. All right, so let's go ahead and move here really quick. And now I want you guys to label it, just so we're all on the same page, label yours A, B, and C. We all have the same triangle we're looking at. So A, B, C. All right, we'll get rid of some of this stuff now. All right, let's read the directions on how to do a median. First, we're going to identify the segment across from the vertex. So we can pick a vertex. Remember, there are 3 medians. So we'll do the median from vertex A. So we'll do that one. All right, what is the segment that is across from this vertex? It is going to be BC, right? Because these two line segments may come together at this vertex. So this is going to be the other side, the opposite side. All right, so what we have to do now is construct a perpendicular bisector of segment BC, which is opposite of our vertex we're looking at. So remember how to do a perpendicular bisector? Remember how to do that? Go more than halfway, right? So we have to put a point here, go more than halfway. Doesn't matter how far, just more than halfway. And then take your ruler, go right through here. Right through the intersection. And make a point. Because the only reason you do that is to find the midpoint. Remember, perpendicular bisector cuts something in half. So we just cut BC in half. So we're interested in that middle point. So that middle point is going to be right here. So that's my midpoint. I don't even need perpendicular bisector anymore, because now that I have the midpoint, perpendicular bisector is not important to me. I just use that to find the midpoint. So now I'm going to go ahead and get rid of this. When I did this on paper, I just erased it. So hopefully you have a pencil. If you're using a pen, it might get kind of messy. You need to really try and keep track. So now the median is going to be what? From the vertex to that midpoint of the opposite side. So now you can just connect that. Connect those two together. Just like this. Right here. There's our median right there. And we can label that point. Label that D. And now we can write AD is median of triangle ABC. All right. So any questions on that? Now, a couple things we know. If we know we have a median, what do we know about CD and BD? They're definitely congruent because the vertex, remember, has to connect to a midpoint. If this is the middle point, that means CD and BD are congruent. So we can say CD is congruent to BD. Just thinking about when you see that you have a median, what are some things we know? Well, we know that. We know CD is congruent to BD. If we had a picture like this and we were given that AD is a median. All right. So now down below, we're going to construct a centroid. All that's different about that is you're going to construct all three medians and then find where they intersect. So, any questions on this? Okay, let's go to the next one. Now, let's label this again ABC so we're all on the same page here.
Is we staying on the same triangle?
No, we're on different. We're going to go down to the bottom triangle. All right. So we're going to label that bottom triangle ABC same way. All right. And we're going to now use the steps above to construct all three medians. So we can do the first one same way. Then we'll just do the other ones. So you're going to need to find a perpendicular bisector of all three segments. So let's just go in order. All right, so do this one again. Yep. Yep, you gotta do all. You're gonna have to do all three eventually.
Wait, what are we doing?
We're on the bottom. We're on the bottom. So we're going to find the centroid now. The only difference with the centroid is you do all three medians, find where they intersect. So on the top we just did the median.
Is this like the point of concurrency?
It is. It is a point of concurrency.
Mister,
Yeah.
can I use one of your reasons?
Yeah. There you go. All right, so do this one the same way. So we did BC up there. I mean, it's a little different triangle, but still the same concept here. All right, so find the midpoint. Remember, the only reason you're using perpendicular bisector is to find the midpoint. So once you have the midpoint, you don't need the other stuff anymore. So I can get rid, or for you guys, erase all right. And that's going to be for A. Be careful, we start getting a lot of lines on here, it gets confusing. But now I'm going to do for B. So if I want to find it for B, what's the side opposite B? AC. Really, you could just find find the midpoint of all three sides of your triangle, and then from there connect your vertexes to the appropriate point.
They don't intersect.
They all should intersect. I'll take a look at it. They should intersect. Did you do this first one, Donis? Did you get this? Okay. Did you do perpendicular bisector of this one? Now I'm doing AC right here.
Can I have that thingy
What thingy?
for this thing?
To tighten it.
Yeah.
Someone have the tightener. Did I give it to somebody? Maya? Alright, so I'm going like this now. And Alright, so now I got my midpoint of AC. I'm going to come over here and put my midpoint right here. And now I can move my perpendicular bisector. I don't need that anymore. Don't need this. Don't need this. Alright, now B, remember this is the side, so our median is going to be from this vertex to here.
Oh, I see, you don't,
So right there. And then we do the last one. Alright, put that through. Okay, that allows me to find my midpoint of segment. Now I'm doing for C. The side opposite C is AB. So now I did perpendicular bisection. Now I don't need these anymore. I have my midpoint. And I'm going to connect there. If I did it perfectly, they all should intersect at one point. And that's pretty good. Probably could have done a little bit better, but alright, so there we go. So I'll let you guys finish that up. I know you guys have to do some erasing and stuff like that. Mhm. And once you do get here, we're going to label our centroid as points. Matter of fact, we're going to label our midpoints. So we have A, B, C, and then we can label this D, E, F. And then our centroid, we can label point G. It doesn't look like you did perpendicular bisector this side, did you? This side? Because I don't see any construction. I see that. But did you do it for this side? Yeah, I think so. Well, I would have seen something like this, or maybe it's small. I'm not seeing anything. I see one. That's for this one? Okay. Well, it should be from here. Yeah, that's obviously not your midpoint, right? Yeah, you got, you know. I do. Okay. All right, label your points.
I know, I was waiting for him to finish.
All right, so okay. All right, good. All right, so label your points. And so we have the midpoints D, E, F. And then I label the centroid as G. Now, if you look at some properties of the centroid, what does it say, number 4? What does it say? The fourth thing I had you write down in your notes about a centroid.
The centroid divides each median in the ratio of 2 to 1.
2 to 1. So that means this centroid, it divides this this median. It divides all three medians in a ratio of 2 to 1. So that means side CG and GE have a ratio of 2 to 1. That means this side is double. So CG is double GE. So if I were to label GE as X, What would I label CG as? So I'm actually going to write that down. I'm going to write that down because that's an important thing for you guys. So if CG, so I'm going to say CG CG equals X. I'm sorry, GE equals X. What is CG? If I told you that the length of GE was equal to X, and we don't know what it is exactly. Let's just say you didn't have rulers, but I told you this is the centroid, GE is X. What would you tell me CG? How could I represent that? Okay, well what if you couldn't figure out what X was? In relation to GE, what does CG have to be? Are they going to be the same? What did Liasia just, well, you guys all have it. Number 4, the centroid divides each median into a ratio of 2 to 1. That means you have an entire median, but it's split up. Part of it is going to be double the other part. 2 to 1, that's what 2 to 1 means. Because like 8 to 4 is 2 to 1, 4 to 2, 10 to 5, 12 to 6. So if this is X, what would this longer one be? Not X squared, that's close though. Because that's not double. X times 2. So right here I can label this as 2X. So whatever this has got to be double. Okay? We could keep doing that all around. If DG, let's just say DG was Y, what would GB have to be? Because again, that's another median. So this has got to be 2 to 1. 2 to 1. So if this is going to be Y, what does this part have to be?
2Y.
That's got to be 2Y.
I said that.
I didn't hear you. I was ignoring you. I was ignoring you. But I think I did hear someone say 2Y. That was you? Okay. I don't believe you. All right. So what if this one was Z right here? So what if GF was Z? What would this be?
2Z.
That'd just be 2Z. Right? So the point is, it's a ratio of 2 to 1. It doesn't matter what the length is. It's a ratio of 2 to 1. All right. Yeah. So you guys remember that you have that homework due tomorrow. Right here. Then right here. Most of it's multiple choice. But I'm probably gonna collect that. We're not gonna have time to go over that. So I'm gonna have to collect that and grade that.
Where's the homework? This one?
Right here, right here. Right here.
I gotta start doing homework now.
I got a class right now. Come back after next period? Or any period after that, I'm free after that.
Packet.
Yep. Let me stop something here. I'm taping this. Okay, I'm going back over the warm-up for this video because I forgot to tape the beginning. So if you're watching this video today, and this is Tuesday, December 8th, this was a warm-up that I gave. So actually, this part that you're watching in the video actually happened before the first part of the video. So the main thing I want you to get out of this is that the larger the side, the larger the angle opposite that side.